Our honored guest for this morning's session is Dr. Michael Watson. Dr. Watson is the co-founder and CEO of OpEx Analytics, an AI firm. He's an adjunct professor at Northwestern University. He's also the lead author of two books, one on supply chain and the other one on analytics. Ladies and gentlemen, it is an honor to present to you Dr. Michael Watson.
Thank you. So in full disclosure, that was a special introduction because Amelia Burles is my niece, and so it was nice to hear her introduce me. I'm sure it was a little awkward for her. When we conceived this talk for this session, this was like back in last summer, and at that point, AI was already pretty important, but ChatGPT hadn't come out yet. And so I thought AI was like a hot topic, and then ChatGPT comes out, and a hot topic became 100x hotter, and everyone I've talked to here in the last few days knows about it. I'm gonna integrate that into the talk and see where that fits in. I'm very passionate about talking about AI and sort of how you think about the whole framework. And of course, when ChatGPT came in, I was excited about that. And what I'm hoping to do today is sort of show you how the whole AI landscape sort of fits together. And my goal is to kind of, inspire leaders and inspire future leaders to think about AI in a holistic way and sort of see, imagine all the possibilities that you can do. And I think one of the themes of this symposium is, reimagine leadership. And I'm pretty convinced that leaders of tomorrow, even leaders of today, if you're not working with data and you're not working with analytics, you have to start thinking about how to incorporate that into your leadership style. So hopefully this is what I'm gonna do with this talk. So the way I like to start is, if we go back to just 2006, 2007, before this, no one was really talking about analytics or AI. Like, groups were doing it, but they were kind of off to the side. And Tom Davenport came out with this book and this article, and they're both still relevant. The article I use still in my classes, and it talked about competing on analytics. And what this article did, like nothing else before it, it woke up leaders all across the US, all across the world to think, I better understand what analytics is all about. I better understand what algorithms are all about. So this book and this article, unlike any other, sort of ignited this movement where leaders realized that this is something important we can't ignore anymore. So this is kind of where it started. It didn't hurt that around the same time, the book Moneyball came out, and then of course, having Brad Pitt in the movie made analytics look pretty cool. So that certainly helped sort of fuel the public imagination, thinking we need to start, we need to incorporate analytics. And then so, as the movement grew, by about 2014, 2015, right in that time, the world had kind of settled on, all right, this is what analytics is all about. It's about these three different things. It's about descriptive analytics, so the visualization, understanding data. It's about predictive, so this is where machine learning fits in. And it was about prescriptive, saying, what should you do? So this was kind of the state of the art just, less than 10 years ago. No AI, no one was talking about AI at this point. So let me do one quick thing. Let me drill in descriptive. When I have a wide audience, I love to talk about descriptive analytics, and I think it fits how, the Air Force Academy thinks about leadership and character, and, it's a little bit about, my section here is about, the living honorably or having integrity. It's a little bit of that, talking about if you're gonna work with data, I want audiences to think about how should you think about data and what are some of the things that can go wrong with data. And I want to start with the first thing, when descriptive analytics, like what can go wrong with descriptive analytics. I want to start with the first thing comes from Michael Schrage, blog post he did. Like sometimes we think about when we're presenting data that our goal is to let's make a beautiful chart. And he says, no, it's not that. It's not the best way of making a beautiful chart with the data. The thing that we want to do is figure out how do we get people to interact with this. And I think this is an important lesson for analytics in general. It's like, our goal, analytics and AI, our goal is not to just tell people what to do and say, okay, here's the answer. Our goal more in organizations is to figure out how can we spark the right kind of conversations between people. So I think this article is a great way to think about how to frame this. It's not about a beautiful chart, it's about how do we get the right conversations going. All right, once we have that, the other thing I like to think about is what can go wrong with this and sort of how can we, mislead people with data. This is kind of a classic chart from Edward Tufte, and he was one of the pioneers of thinking about data visualization. And I like to ask, smaller groups, what's wrong with this chart? And what it's showing is miles per gallon that cars got in 1978 versus 85. And when I say what's wrong with it, it's pretty easy to see that this is like a classic terrible chart. And one of the things that should jump out at you is that if you look at in 78, the average miles per gallon was 18, and it grew to 27.5. And so, like, all right, 27.5 is bigger than 18. We'll all agree with that, but it doesn't seem like it's that much bigger than 17. And so what Tufte's coming up with here, and I think this is a good principle as you think about your presentations and your visualizations, is the lie factor. Like, how much ink are you giving to a piece of data versus how much ink is really worth giving there? And so when you look at that chart, what makes it wrong is that we have this huge lie factor. We should be close to 1, and here this lie factor is like 14.8. So the data point for 1985 is 14.8, too big relative to what we're trying to say. And so I like this, the math behind it. I like kind of pointing this out because it's, when we do these graphs, we want to make sure that, we're presenting the data in the most truthful way that we can. And this is a good sort of way to start thinking about that. The other way is sort of an accidental way. It's not necessarily a lie factor, but it's another way to think about it. And so here's a chart of a French company, and it's showing how big the company was. That's the gray bubble before the recession, and then how much it shrunk. And so if you quickly just, what's your intuition how much it shrank from the gray to the dark gray? Half? Yeah, half. So half is like the answer that most people come up with. And so this is an example, not intentionally misleading, but it's misleading in another way. If I did it in a bar chart, the exact same data, it's very clear that, this is only a third. It shrank by a third, so it shrank by much more than a half. So why did everyone say half? That's like the answer that everyone always gives. Well, it turns out us humans, we're terrible at estimating area and comparing two areas. Like, we're not good at it. And so we use a heuristic, and our heuristic is, well, I can't figure out how big these bubbles are, but I can figure out how tall the bubbles are, and I'll compare the height of the two bubbles. And if you line up the height, it's like, well, the small bubble is half the height. So that's why we all intuitively thought half. So another sort of tip on if you want to convey the truth about the data, make sure that your human readers are going to understand the same data that you're presenting to them. And then the last one here is this kind of famous one from Steve Jobs and Apple, showing market share of the iPhone at some point, like 2008, 2009, somewhere in there. And so what he did, if you look at this graph and say, what's wrong with this? Well, this, the Apple's 19.5%, that piece of the pie chart looks a lot bigger than some of the other slices that are larger. So I put some just little simple PowerPoint things there, and then I moved it over to the 21. It's like, yeah, the 19.5 is a lot bigger than that. And so, and even close to the 39. And so what was happening, is, or I guess that's, the point there is if you want to lie with your pie chart data, put the slice of the pie that you're most interested in at the bottom, and then do the 3D effect. So the 3D effect always gives you this more ink and sort of expands it. And then in general, so even without the 3D, a lot of people don't like pie charts just because it's hard to compare areas. So it's exactly the same as our example of the two circles. If you want some more information on sort of good visualization, I like this book, Storytelling with Data. I think she does a great job of sort of highlighting some of these kinds of things. So this is my little pitch on descriptive analytics. All right, let's get back to sort of what became AI. So 2014, 2015, people were really excited about predictive and prescriptive. So there's a lot of excitement here, and I want to kind of get the feel for why were people excited. So this first example is, what was new about these machine learning algorithms? Like, something was new and different. And what was new and different is we had a lot more power with the algorithm. So if we look at a traditional approach, so this is a very simple example where we're just trying to predict, is a dot going to be orange or blue? And it's a very traditional approach. You have an algorithm that would draw a line through the middle of this, a regression line, and say, okay, everything above this is orange, and everything below it is blue for prediction. It's not bad. And then if we had a new dot, we just looked, is it above or below the line, and we'd make that prediction. What machine learning did is it introduced all these new algorithms. And so we had these algorithms that could tease out and find new patterns. And so in this case, it found this little peninsula of orange. And so presumably this algorithm would be better at predicting. So now anything above the line is orange, below is blue. You see that prediction capability got better. There's fewer mistakes. So what I like to point out with this is a couple things. One thing is that, oftentimes when people hear machine learning, they think perfection. And if you look at the thing on the right, it's a machine learning algorithm. It's not perfect. Like, there's some errors in there and that. And the other thing I like to point out, or just started pointing out, is, it's okay, this is a super simple example. But if we think of ChatGPT, So ChatGPT is really basically doing something similar to this. It's making predictions on what the next word should be. So when you type in a prompt and ask it a question, it's basically looking at the words and then predicting what next words it should do. So it's doing a prediction. Now, it's a lot more sophisticated. So this one on the right there has about 2 or 3 knobs that you can play around with. And then the one, the ChatGPT has some unimaginable, something like 178 billion different knobs that you can turn. So it's a more sophisticated, but at some level, it's still doing some type of prediction. So that's why people got excited about machine learning. Like, all right, we can tease out and find these new patterns that we hadn't seen before. The other thing that I think was interesting and kind of got people excited is, like, what's this word learning mean? Like, what does it mean for a machine to learn? Like, we all went to school, we all learned, we had an idea what it meant for us to learn, but what's it mean for a machine to learn? And a good example of this is thinking about how do we figure out automatically what's a good potato chip and a bad potato chip. So if we're doing quality control, how can we automate that particular process? And so what machine learning was going to replace was a system of a rules-based system. So this was kind of the previous wave of thinking about how to automate this stuff. So what would you do if you had a rules-based system? What you would do is you'd get a bunch of people, a bunch of your engineers into a room, and they would write out all kinds of formulas about what to find a good potato chip and a bad potato chip. Its shape, its color, all those kinds of things would be calculated, and then every new potato chip, you'd compare it to those formulas. So that's an okay system, and I think a lot of people probably gone through that, and there's lots of these rules-based systems in practice. But what happens, and what the problem is that turns out there's too many rules. It's actually very hard to write down all the rules for even something as simple as like what's a good potato chip and a bad potato chip. And somehow if you've managed to sort of muscle through the process once, like if something changes, like, well, the market now wants bigger potato chips, or they want barbecue potato chips, we gotta get everyone back in the room and rewrite these rules. And so that becomes like a big headache, and no one wants to do that, and these systems tended to break down. So this is why people got excited about the learning part. So what was the learning in machine learning? So the learning here was that we're just gonna let the machine itself figure out what's good and bad, and all we're gonna tell it is give it a set of pictures and say, here's a bunch of pictures of potato chips, this one's good, this one's bad, this one's good, good, bad, and it has these pictures, and then the algorithm can then figure out itself sort of what makes a good and a bad potato chip. Now, the algorithm doesn't necessarily give you the formula. It's kind of like a black box. It doesn't tell you what it's necessarily doing, but it was being able to do this. And this got people excited for different reasons. And one is like, now that you can imagine, like, I don't have to do the rules. If potato chips change, I can just quickly give it a new set of pictures and good and bad potato chips, and the algorithm can take over. And then as I feed it more and more data, presumably the algorithms will get better and better. And we've seen this a lot with machine learning is I add more data, I get better and better results. So I think that's the thing that got people very excited about the machine learning part. All right, and here's a quick example of, how does data make machine learning better, and sort of talks about the evolution. So let's think about something simple like forecasting how much I'm gonna sell of Diet Coke. And so the traditional approach would have been just a simple time series model. We're just looking at how much Diet Coke did I sell, every week for the last 2 years, and then I'll use that, use some simple time series models and predict what the sales are gonna be for the next 4 weeks. So that's one way. And then with machine learning and extra data, the first step here was, can we add external variables? So, can we add weather? Can we add some demographic information? And this starts to make the predictions better. And then it gets even better on top of that, where we start to add these engineering variables. And this is where, for all the people who are sort of new in your careers in this, or you're a leader of groups, this is where a lot of the creativity is can you come up with the right set of engineered variables that they'll help the algorithm make better predictions. And this could be lag variables, this could be combining different variables together and things like that. There's kind of a classic example of that, and it came from the world of online car auctions. In an online car auction, like the way it's set up, or these were set up, is you have to sort of buy just based on the specs. Like, you don't get to drive the car, you don't get to inspect it, you don't get to look at it, you just look at the specs, and you have to make a decision to buy or not. And so they're trying to figure out, is there a way to figure out what's a good car and a bad car just based on the specs? And people were doing the analysis, they could tell that the color of the car somehow mattered, but they couldn't quite get it right. Like, just being very direct with the color, this one's red, this one's orange, this one's green, wasn't quite helping. And it was this creative feature engineering, or coming up with like a new variable. And the new variable was, let's just look at standard color cars, so the gray, the black, the white, versus unusual colors, and that turned out to have a lot of predictive power. And then what people later figured out is like, why was that true? This is often the case, like the algorithm finds the answer and then later you figure out why, and the why kind of turned out, well, if you bothered to own an unusual car, you might like cars. And if you like cars, you might take care of it better, and so it tended to sort of give you a lift there. But for this example, I like it because of the creativity. Like it showed us like thinking about the variables in a different way unlocks some prediction power. All right, so this is kind of where we all were before we started talking about AI. Like cool stuff was happening, lots of progress was being made, like companies, organizations were all starting to adopt this. And then let's talk about sort of AI and sort of its impact and sort of where it came from. So the key year for AI is really 2012. AI in its latest incarnation was 2012. So what happened was there was this use of neural networks. So a neural network works basically the way we think a brain works. We don't actually know how a brain works, but it works kind of the way we think a brain works. And what they were able to do in 2012 is they had some breakthroughs with image recognition. So this is the first time that a machine could recognize images better than a person could. And so this was a big breakthrough, and the researchers at the time, since they were using a neural network, they said, okay, this is AI. And then what happened was, the term AI, pretty cool term, it really caught on. It sort of caught on, it kind of spread to other domains, and then it basically went viral, the term itself. And at this point, in 2023, I think it's important for us to think that, AI is really being used in 3 different ways. And it's important to know these 3 ways, because I think it's, for the young cadets in the room, it means like 3 different career paths, like 3 different things that you can do with your career. And then for sort of, leadership, it means like, all right, there's 3 different types of projects we should think about. And I think it's important that we categorize these so we understand sort of what we're doing with AI. So let me go through the 3 definitions and some of the examples. So definition number 1, so when people say AI, oftentimes they're referring to artificial general intelligence, AGI. And what this is getting machines to think exactly like people and be able to reason just like people and have general intelligence. So you can have a machine that you can feed it any kind of problem, any kind of situation, and it'll think through it just like a person would think through it. So this is the goal of AGI, or sometimes what people are talking about. One of the famous people who talk about this space is Ray Kurzweil, and he has this idea of the singularity, which is where basically the machines get smarter than us, and once they become smarter than us, then they can make machines that are smarter than them, and sort of basically the idea is like, okay, this is the scenario where humans just get completely left behind. And this is, if you think about where Terminator scenarios come from, it's this definition. When people are thinking about that, they're thinking about artificial general intelligence. So that's one area of research, and it's hard to say, but I think you can categorize like things like self-driving cars in here, although I suspect once we get a self-driving car, let's assume it works, and it works really well, I have a feeling at that point we'll say, that wasn't really that hard. We still need to, there's something else harder for general intelligence. They can drive a car, but it can't do general intelligence. So there's these kinds of things with AGI. So that's kind of one definition. Now, there's a lot of work in here, and a lot of the research coming out of here sort of feeds others. And so let me go to the next one. And so, I should talk about this. So, yeah, AGI is, this is cutting edge. And if you're young in your career and you want to get into this area of it, like this is hardcore PhD level kind of research. It's like, the organizations that are doing this are sort of tapping into that PhD level market, even hiring, PhD level professors to sort of come in and work on this stuff. It may turn out it's not possible. I'm for sure, everyone tends to ask when you do a talk on AI, like where you stand. I for sure stand on the skeptical side. Like I'm not convinced that it's going to be possible or that we're even close. But people who are a lot smarter than me and more accomplished than me think it's possible. So I'll hedge with that. And for sure, somewhere in the DoD, there's groups of people that are working on this deep in some lab. I don't have any access to that, but it would be negligence if there wasn't a group that was working on this particular thing and sort of doing this kind of research. All right, so let's look at the next one. So the next one is generative AI, and this is where ChatGPT will fit in, but I'll get to that in a second. So generative AI is basically you have some kind of prompt, and the AI engine comes back with something that looks creative. So the first stab at this was not too long ago, about a little over a year ago. DALL-E came out. You know DALL-E? People know that? All right, so this is like the early incarnation of ChatGPT, but it was for drawing. So you type in a prompt and it draws a picture. And so like the picture on the far right, the cartoon on the right there in the middle, I was supposed to do a tandem jump when I came out here on Wednesday, but the weather didn't cooperate. So in anticipation of that, I asked Dolly, I said, draw a cartoon of a guy doing a tandem jump at the Air Force Academy. I have to say, I was a little nervous to do the tandem jump, but I was going to do it. And it drew that picture. I'm like, man, I do hope I'm strapped in a little tighter to whoever's jumping with me than that picture drew. But that's the kind of stuff that it did, and sort of started sparking the imagination. And there's other things it can do, like make fake interviews from people, so everyone's kind of heard about deep fakes. This is where this is coming from. And then, of course, we have to talk about ChatGPT, because everyone knows this. And so I just did something simple and typed in, like, all right, what's the strategic use of the Air Force? And it came up with an essay. Like, I didn't tell it what kind of essay, wrote this nice little bulleted essay, and like, I kind of learned something from this essay. Like, it does a pretty good job, as I think you guys have all seen. So, first thing I should point out, I think generative AI is not AGI. Like, this stuff looks like it may be coming from general intelligence. It's not. We talked about it at the beginning. What it's doing is it's just predicting, what the next word's going to do, and it's good at that because it has these, 175 billion different knobs and parameters it can play with, and it's trained on a lot of data. What is it? And how should we think about this? So the first thing I should say is it's completely new. If we come here next year and start talking about it, I'm sure it will have evolved and changed from sort of what we thought today. So it's a pretty exciting field. I'm sure it's going to have a lot of impact. So it's already having an impact on people who are writing programs, because you can get very good blocks of code and sort of get some good information there. You've seen the writing and the essays, so it's definitely going to sort of change how we think about that. As an adjunct professor, as a school, like, for sure we're going to have to think about how we grade, evaluate, and do essays in our classrooms. It's going to change that kind of thing. Hopefully it's going to bring out some creativity. No one knows how it's going to shake out yet. Like, there's hundreds of different companies that are forming and hundreds of different ideas. But the other thing I should point out is you don't need technical details to get into this. Like, this is not a technical field. Like, AGI is very technical. You need to understand the details if you want to work in that field. This one is, just understand what the thing's doing and just be able to interface with it to build different applications, be creative, and take advantage of it. All right, so that's two definitions, and I think there's still a third, and this is the third definition. Tends to get lost in the first two, but I think this is the most important definition to the people in this room and to general organizations and general businesses, is that most of the people are going to be doing some form of practical AI. So this is still a version of AI. It's still using some of the same techniques, so deep learning, reinforcement learning, but it uses others, optimization and machine learning. What makes this one different is this one's all about just solving particular business problems or organizational problems. So, my gut feel is, in what I've seen in the world, like, AGI is complete research. Generative AI is very new. We're still trying to figure out that. But then there's this whole other area of AI, which is practical, what I'm calling here practical AI, about solving the particular problems that we face using a collection of algorithms. And a lot of people will say that, to do AI, you have to use deep learning, which is, where we started in 2012. Totally don't agree with that. That's not how people use the term. So if you go talk to a business leader, an organizational leader, when they talk about AI, they're probably talking about practical AI. So let's give some examples of how this works. Here's a pretty simple one. So I was involved in a project with the Houston Food Bank right when COVID hit and right when sort of everything shut down. And what happened here was, if you remember, like, unemployment just had this huge spike, and that huge spike led to a huge rush in demand at places like the Houston Food Bank, which I think might be the largest food bank in the US, like one or two. It's pretty high up there. But anyway, so what they were doing and how they used AI and analytics to think about their problem, they kind of broke it down into three different phases. The first one was just kind of the descriptive phase, just kind of what happened. So, get some situational awareness, like what's going on, what's really happening in this network, the churches and community centers, like, are they open, are they closed, what are they doing, how much inventory do I have, who's donating food, who needs food, et cetera. Then the second thing, once they had that, they started to understand and use predictive algorithms and some machine learning algorithms to predict what's coming next. Where's the next demand point going to be? Where's supply coming from? Can I understand that? And then finally, they had to have the last component is like, well, what should I do? And they even at some point, like many places, they brought in the National Guard to help figure out, where should I position the National Guard? How should they help deliver food? What news stations should we open? Where should those stations be? So I think a nice little contained example that hits a lot of different algorithms. There was no deep learning in here. There was nothing that would indicate that you were doing something general intelligence, but it was business, solving a particular business problem using all the algorithms that you had available. Another good example of AI in an organization is John Deere. And I like the John Deere example because this is, basically as traditional as you get, big farming equipment. They jumped on to the AI bandwagon pretty early. So they had a commitment to this pretty early. And what they were doing is they basically took a whole lot of steps on their journey. And their initial steps started with, can we collect data? So if you can collect farm data about the soil, that kind of thing, you can actually increase the yields quite a bit. And so they were trying to provide this information to their farmers and their customers, where should you plant the seed, how much seed should you plant, how much fertilizer, how much herbicide should you plant, like all this kind of information to sort of make the farmers more productive. I think they're on their journey to, can they have self-driving tractors and sort of do more and more productivity enhancements. And then it also helped John Deere because they could start to understand the needs of their customer better and incorporate that into their product. So I think a good organizational case study of this. Another good one is NFL scheduling. So I was at superintendent's house for one of the kickoff sessions, and General Clark was saying that after this event ends, like come Monday, the planning team will start working on next year's event. It's exactly what happens with the NFL. Super Bowl ends the next Monday. They get in a room and they figure out, what's the schedule going to look like for next year. And I think this is a good example too for this group because I think it highlights a lot of interesting aspects of the problem. So what's interesting about the NFL problem? So you can see some of the rules up there that they have to follow as they build these schedules. It turns out this is a big optimization problem. So it's like a huge problem trying to figure out all the different possibilities of how you're going to set up this schedule. There's all these different rules, and the rules are some of them are firm, and then some of them are well, we really like to have it, so it's kind of a messy set of rules. And then it has this lots of different stakeholders. So, the teams care, and the coaches care, and the fans care, and they'll talk about this. And the broadcasters care because, they're getting money for this, and so the broadcasters want good games too. As I was thinking about you guys, why I put this up here for this symposium, it's if I look at those first three, it's these are the kind of problems that you're going to face. They're going to be big, they're going to be messy, and you're going to have lots of different people that you have to please to get the solution implemented. So exactly the same thing that the NFL went through. Then there's kind of some additional things that sort of pop up in different problems, like understanding what's the value of a game. And in just general terms, is what's the value of different assets that you have? So I can, imagine some military applications where you're trying to figure out, what's the value of all these different assets that I have in the field? Can we predict next year's big game? So adding some predictive power in here to sort of understand that. And then finally, just doing some analysis, you get so many rules like this, which rules are actually really good and worth keeping and which ones aren't. And the example they use is that coaches complain to no end if you make them play three road games on the road. And so what they wanted to do is kind of look at the data and say, does it really matter when teams play 3 road games on the road? Does it really impact their wins and losses or not? And so it's those kinds of things like questioning the rules and questioning sort of standard operating procedures. Another good book and another way to think about the AI movement came from this book, Prediction Machine. So I highly recommend this book. And the framing of this book is written by economists. And they were thinking what's going to be the impact of the power of prediction? And they had this really nice way to think about it. And they said, if we can reframe a problem as a prediction problem, we can use an algorithm to predict an algorithm instead of a human, so reframe the problem. And then they said, by the way, a lot of problems are prediction problems. So, we just talked about the NFL, predict what games are going to be important next year. That's a prediction problem. But ChatGPT is a prediction problem. It's just predicting, what word's going to come next in a series as it writes an essay. So there's all these different creative ways. If we can reframe problems as prediction problems, we can apply these algorithms. And I think they did a good job of saying, okay, as I have these more algorithms and more predictions, it also means I need to have more judgment and use more judgment. So, they gave a good example that said, if I predict it's going to rain, there's a 60% chance that it's going to rain, I need judgment to say, am I going to bring an umbrella or not? And that could depend on a lot of different things. And they kind of have that framing in there that you need this judgment to go with the prediction. And I think too, they, the other thing they think about is, or you can think about is that you can even replace some judgment, not all, with optimization if it's a standard type of problem, like you're routing vehicles or scheduling personnel. And then some examples of reframing as a prediction problem. So the first example here comes from This is work from basically an online retailer, and they were looking at when people order product, does it get there in time or does it not? And can I figure out the root cause? So the root cause doesn't necessarily seem like a prediction problem, but if we reframe it and think, can we look at all the data that led up to a failure and sort of predict what are the data elements that led up to a failure? And this is a good example of, can I collect more and more information? So a lot of root cause type of problems just are very simple and sort of superficial, only go like one level deep. But if I can look at the chain of events that happen in an online order, like someone went online, they clicked purchase, they went through a fraud check, the fraud check cleared, the order was dropped to the warehouse picked it. So you have all these different steps, and as I look at those steps, can I get some sense of sort of why one order might have made it or might not have? And I've seen lots of different applications of this, like Michelin's doing the same thing. Is like, can I predict when these failures are going to happen in my supply chain? So it's a good way to think about reframing the problem into a prediction problem, and then I can apply some algorithms to get some new insights. Another good example, I didn't think when I put the slide together, I put BNSF up there. It's not BNFS, this did not come from them. It was just on heavy equipment. So I've seen railroads, I've heard talks from United Airlines. It's changing the problem of worker safety. So there's all kinds of things we can do for worker safety. But another one is, can we turn this into a prediction problem? Can we look at the data that we have and make some kind of predictions about which operators or which operations might lead to some kind of injury or some kind of fault, and use that information proactively? I think United had a good example, and I heard a talk from them where they were looking at who was actually working at each station. So these are the people that were on the ground at the airport. So they called it under the wing team. Who was actually working, sort of what their background, sort of what had happened before, if they worked long shifts or not, like what the load was going to be that day, what the weather was going to be that day, and they could tailor messages to the supervisor to say, these are the things that we should watch out for today in this particular airport versus that airport. So changing the problem into a prediction problem. If you want to think about sort of how this works in an organization, how you do it at scale, like the other thing I think about the AI movement is that if you have one algorithm in your organization, it's like, all right, that's cool, but what you really want to think is like, how do I think about algorithms across the organization? And this is a great book and a great reference for doing that. Like I like the first 5 chapters of it for that, which is about 2/3 of the book. They talk about, how do you implement this at scale? And they talk about you need a data layer. So any organization of any size has a lot of data. Like, are you collecting all that data, and can different groups in your organization access the same data? And then after you have that layer, then you have this algorithm layer where different groups are building different algorithms to take advantage of that data, help make decisions. And you still need the software layer so that you can get that information out to someone to take action, whether it's an automated action or whether it's information you put in front of someone. So I think a good framework for thinking about that. Whoops. All right, so now let me wrap it up here by talking about, how should both leaders and people who are getting into the field, future leaders and future data scientists, sort of think about this particular career. Like, how do you think about a team? How do you think about the talent? How do you think about, what's going to be your role within this big space? I think the mistake that people make, I think they make it less now, but for sure, a few years ago, it made it a lot more. But the mistake people make is they tend to think, when I think about a data scientist, someone who's going to do this work, I tend to think of like a decathlete. Like, this person can do everything. They can write Python, they understand deep learning, they know optimization, they can build software, et cetera, et cetera, et cetera. Like, there's an all-around unicorn type of person. And this is the wrong way to think about it. Like, if you think about this, you'll only be frustrated, or you'll only decide to pursue a career in something else. Instead, I'd like you to think about Ocean's 11 is your model for what these teams look like. So if you remember Ocean's 11, every character in here had like a very specific and niche role. And that's how data science teams are structured, and the best ones kind of follow this particular pattern. And what are those different skills? So the ones at the top here, these are your more technical, these people know the algorithms. So they know machine learning algorithms, they know the deep learning algorithms, they know optimization, so they know how the algorithms work. And then you have a layer of people who actually sort of make this stuff work. So the group at the top does, maybe they just do the testing and sort of get the prototypes built, but I need software engineers and data engineers to actually turn that into something that works at scale. And so that's that kind of group at the middle. And then you see some other groups like, product manager and designer. Like, you need people who watch over this. So this is not only a technical thing. You've got to, take the best practices from the last, 2 or 3 decades, like apply that to your machine learning teams as well. And there's one role I like to point out more than the others, and we have this idea of there's a role for a person who's a translator, and this is an important role. So this is a role for someone who understands the algorithms, like understands enough about the algorithms to know what they can and can't do, and can talk to the algorithm team. They know enough about the software engineering, they can talk to that team, and they also know and can talk to the business team and the business leaders. So I think this is the kind of skill that's needed. Oftentimes, when I talk to crowds of undergraduates, this role kind of gets forgotten, but it's a good role, like to understand the technical details enough, but then get yourself in a position to maybe understand the business so that you can act as this business translator. And then also as business leaders, I like to think that a business leader is probably not going to be able to play this translator role, maybe only a tiny bit, but they'll need to have people on their staff that they can go to who do play this translator role. And it was kind of only after we had thought about this and sort of seen it in action, I kind of realized I've spent my career doing this, is sort of diving in and understand the technical details enough, and then understand the business side and bringing those together. So I put this out as like, okay, this is a thing that we should think about as you think about your careers and how you build these different teams. All right, so with that, I will open it up to questions. I appreciate your attention. And I think there's microphones on either side. And any questions, fair game. Yes? The translator, I haven't had a good description of it. Like translator's been the best one I've come up with, so it's some version of that. Because it's not a role that fits naturally in a lot of organizations. Like if this was a commercial audience, like there's industry roles that are kind of this role, like where you're doing technical sales. A lot of technical people like to stay away from sales because they think it's this weird, icky kind of field. But if you're in technical sales, you have to talk to the business and you have to know the technical stuff. But inside a big corporation or inside like organizations like the Air Force, it's harder to have this role as something that people have realized that they need, but you need to find this and you need to carve this out. I guess that's the message. Yes? Yeah, okay, so the question was, so the microphone's here, so the question was, is it kind of creepy and weird that the algorithm's like, it tells you the answer, but you don't know what it's doing? And the answer is like, yes, this is one of the downsides, and there's this whole area of AI research that's built on figuring out why the computer said what it did. Like in deep learning image recognition, for example, I know there's a lot of people who are working on, okay, we recognize that this image was a horse. Why do we recognize that this is a horse? And that turns out it's a very hard problem. So this is something that we have to deal with. Like, for example, the banking industry they may have changed recently, but they've kind of refused to use some of these new algorithms, although the algorithms would help them make better predictions and help actually make the banking system more robust. No one knows why the algorithm came out with what it did, and so they've stuck with more traditional statistical approaches where they could get that answer. So this is a big issue in the field of AI. It's like, why did it come up? Like ChatGPT, no one knows like why it came up with it, the essay that it did. And I have a feeling that we'll continue to have to sort of deal with that. Some things it doesn't matter, like, if you're predicting a good or bad potato chip, like, I don't care. It's like good enough that it told me it's bad, and I'll take its word for it. But other things you can see can get more ethical pretty quickly. Yes?
Yeah, thank you for the talk. So in the DoD, there's lots of data available. We've got oodles of it, and lots of people want some AI, as if you could like buy it off the shelf. But I think often there's a struggle to take the data and normalize it, do the things that kind of get you into the first parts of the pipeline so we could start using it in the first place. Could you talk a little bit about how, going forward, entering the Air Force, even maybe non-technical people can influence that, or? Okay,
so yeah, the big question, yeah, so I kind of downplayed a little bit. I talked about the role, there's a role of this data engineer. The book, Competing in the Age of AI, talked about, building a data layer. And as you do these kind of projects, what you should think of is that 80% of your time is going to be spent on collecting, gathering, cleaning, working with a particular data set. So, my first tip is like, expect that. Like, I think a lot of people think, oh, this machine learning is pretty cool. We're just going to go in and apply some algorithms. They don't realize that there's a lot of this kind of work. So I think there's one, just resetting the expectations that I do have a lot of this data work that we have to do. And I think that, companies who are on the leading edge of this do at a corporate level, at a high level, do spend years sort of getting their data in a format that's readily available for the organization and that the organization can tap into. Like, this is a sort of important, often overlooked part is like a company like Amazon, for example, has spent a lot of time sort of collecting all this data to let the other groups in the organization use that data. So you need to spend that time. Like, do I have any great tips that are like, silver bullets? Like, absolutely not. Like, so I've spent probably in my career, probably the majority has been the commercial side for sure, but I have dabbled into talking to different military groups about some of this. And, I think my advice to you is that I've noticed that, compared to the commercial world, the military locks down the data a lot harder than in the commercial world. And there's going to be some kind of trade-off between, I know the data here is more sensitive and there's all kinds of good reasons for that, but you have to start thinking like, where is that line that you're going to draw here in the overall DoD? And because the more you open up the data, the more you can open up to the ability of some of these algorithms to make better decisions. I know that, you have to weigh the security risk and all that, but I guess that would be sort of a challenge too I would present to this group, is like thinking about where that line should be as you start looking at this data, like how can you open it up more without exposing yourself so that you can get access to these algorithms and these results. I don't know, is that helpful? All right.
So when you spoke about AGI, general intelligence, you said that you were skeptical of it even being possible, much less viable. Could you go a little bit more into that?
Yeah, so all right, so there's different schools of thought. So Ray Kurzweil, he's a smart guy. Elon Musk, I think he'll tell you he's worried about it. So other people of that caliber are worried. There's a whole other set of people who say that they're not worried. When I look at both, I tend to go with the not worried side. I think there's some skepticism out there that, right now all the research is around these deep learning algorithms. And there's some skepticism that says, okay, that's one aspect of it, but we're not convinced we've, completely solved general intelligence with this. This might not be the right way. It might be very good at predictive. It might be able to write nice essays, but maybe writing essays turns out it wasn't as hard as we thought it was. It wasn't what made us have human intelligence. There's things like, there's authors out there who will say, we haven't really defined, what is general intelligence. So we're kind of going at it the other way. We're building better and better deep learning algorithms that tackle different problems, but we're not going at it from the direction that says, here's what general intelligence means. I don't think people have an understanding of that. And a good example that I like to think of in my head is if I asked us all to write down the directions for how do you ride a bicycle, no one, how do you ride a bicycle without falling off and then expect someone to read it who's never ridden a bicycle? They're not going to be able to do it. There's a whole bunch of this intelligence that's very, you can't articulate it, you can't write it down, there's no data on it. We've had to sort of live it and feel it. And so I don't think AI is sort of tapped into that yet. It's kind of some of the reasons I'm skeptical. I'm hedging too, I could still be wrong, but that's where I end up.
Morning, sir. I just had a question about the AI. So, in your opinion, do you think society at large should be able to trust AI to the point where it can run a lot of its systems, like its banking, transportation of goods, or do you think there should always be a human element involved?
Yeah, so my feeling is for sure there should be a human element, just based on my general skepticism. I don't think AI is ready to run whole organizations. I think you have to have smart people and dedicated leaders who are happy to apply the algorithms, but they're watching over the algorithms too to make sure that they're doing the right thing. Now, I think there's a lot of things that you can completely automate and there's no ethical issues like detecting good and bad potato chips. There's no implications that if that algorithm messes up, no one's hurt. But there's other things, the legal department is a big one. It's I'm convinced two things. I'm convinced, one, algorithms could probably help judges make better decisions, and I'm convinced that you need judges to still watch over it. I think, I worry that we swing one way or the other, say, okay, we can't trust any algorithm. I bet you some algorithms could help a little bit inform that. But it's not going, my feeling is it's this stuff, these algorithms aren't going away. We're going to have to use them. We're going to have to learn how to live with them. But I don't think they're anywhere near ready to run an organization or make really big strategic decisions. Welcome.
Good morning, sir.
Good morning.
So you mentioned fraud earlier, which is my area in my career right now. What I'm wondering is, I know that AI is now becoming or has become a part of fraud investigations, as well as prevention and detection. So primarily, we get a lot of small businesses that really aren't tapped into AI. How do you get them involved in that and get them started on having AI and using it to actually find out what their risks are and all?
Yeah, so small organizations have tended to be a little bit left behind by some of this movement because, they don't tend to be connected to systems. But, what I have seen over the last few years is that even these small companies have some kind of, data they're collecting on their operations and sort of how they're running business. And I think there's a concept that at a company that I used to be involved with called Coupa that was this idea of community data. And I think, as time goes on, more of these small businesses will contribute their data to the community, and then they'll get benefit from looking across the whole spectrum. So, if I'm a small business, I contribute my data to the community, then maybe, there's enough data, enough of these small vendors out there that when we do fraud detection, that someone else over here has a problem, and then all of a sudden that fraudster shows up at my shop, then I can get some kind of alert. Where if I just did it with my own data, I just wouldn't be able to see this person trying to break into my system or commit some kind of fraud against me. So I think there might be something like that where smaller players start to contribute their data to a broader community set of data that's protected and anonymized, but still they get the access of that. Yeah, thank you. Other questions? All right, appreciate your time. Thank you.
Dr. Watson, thank you for your message this morning. Your experiences and perspectives speak to how we can reimagine leadership and inspire teamwork. On behalf of the U.S. Air Force Academy and our National Character and Leadership Symposium, please accept this token of our gratitude. The base of this gift is made from marble from our terrazzo. This is significant to us because all cadets have had to run the marble strips during their freshman year. We hope you will look on this and remember your NCLS experience fondly.
Thank you. All right, thank you.
This concludes our session. We encourage you to stop by our testimonial booth on the south side of the Arnold Hall foyer, where you can record an audio or video review of this session and your overall thoughts on NCLS 2023. Cadets, you can use the session or check in for this session using the posted QR code. Thank you and have a wonderful day.